Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the gravitational potential of a solid sphere. So we know that the gravitational field intensity outside the solid sphere is equal to the gravitational field intensity outside the hollow sphere. Their formula is same, which is gm by r square, and on the surface it is also same, it is gm by capital R square, but inside the gravitational field is different. So I inside in the solid sphere is gmr upon r cube. Okay, so we can predict that the formula of gravitational potential due to this solid sphere outside as well as on the surface would be same as was in the case of hollow sphere, and therefore we can say that V outside will be equal to minus of gm by small r, and V surface will be equal to minus of gm by capital R. Now we have to find out the potential due to a solid sphere inside the sphere. So now we know that the gravitational field inside this solid sphere is gmr by r cube, where small r is the instantaneous distance from the center of the sphere. So we can say that dv is equal to minus of I dot dr, and dv, let's suppose there is a point A which is at a distance of r from the center, and there is a point B on the surface. So we are moving from A to B like that. So VB minus VA will be equal to minus of I, which is gm r by r cube, and the direction of I is towards the center, and the dr vector is from A to B away from the center. Therefore there would be a negative sign and this would be positive. Okay, and the limit of this would be from R to capital R. So VB minus VA. Now VB is, we know B is the point on the surface, so VB is minus gm by R, and VA is unknown which we have to find out, and this is equal to gm by 2r cube, and this is r square minus r square. Okay, so VA will be equal to minus VA will be equal to gm by 2r cube into r square minus r square minus, in fact, plus gm by r. So you can see that VA will be equal to minus of gm by 2r cube into 3r square minus r square. Okay, you can check this formula from here, and you can also see that at the center of the sphere, center of a sphere, small r is 0, therefore VA at center, which is VC, so it would be minus gm by 2r, in fact 3 by 2 gm by r with a negative sign. This is the potential at the center of the solid sphere, and at r is equal to r, you can substitute the values of small r as capital R here. So you can see that V surface will be equal to minus of gm by r. And if we plot the graph of the gravitational potential of this sphere, then obviously it would be negative, and initially there would be inside the sphere there would be a relationship between VA and R, and this relationship is a parabola which is opening towards positive side. So it would be like that. and outside the sphere it would be hyperbola. So this would be the graph. And this is the surface, and at the surface potential is minus gm by r, and at the center potential is minus 3 by 2 gm by r, and outside it is hyperbolic relationship. V magnitude is inversely proportional to r. Okay, so this is the graph of this potential of a solid sphere. Now let us discuss the gravitational potential of a ring. We know that the gravitational field intensity due to a ring is gmx by x square plus r square to the power 3 by 2. Okay, so to find out the gravitational potential due to a ring, we have to assume 2 points. Let us assume that one point is this one and the other point is infinity. So we are moving from this point P to infinity. So dV would be equal to minus of integration I dot dr, and dV will be the final potential minus initial potential, and this would be equal to minus of I, which is I is in the backward direction like that, and dr is in forward direction. So I dot dr would be negative, and there would be a negative sign which would make this negative as positive, and I would be equal to gm by gm r by r square plus r square to the power 3 by 2 into dr. Okay, so Vp will be equal to minus of gm integration, this is r dr upon r square plus r square to the power 3 by 2, and the limit would be from p to infinity, therefore it would be from r to infinity. Now to integrate this term, let us assume that r square plus capital R square is equal to z square, and therefore 2r dr is equal to 2z dz, and r dr is equal to z dz. So by substituting these values, we can say that Vp is equal to minus gm, Vp is equal to minus gm, and the integration would be like that r dr is z dz, and this z square to the power 3 by 2 would be z cube, and the limit would be from r to infinity. So Vp will be equal to minus gm, and this would be integration dz by z square, and limit would be from r to infinity. Now the integration of 1 upon z square is equal to minus 1 upon z, and therefore plus 1 upon z, and it would be from r to infinity, and Vp is equal to gm by gm into z, where 1 upon z is under root of r square plus capital R square, and the limit would be from r to infinity. So Vp will be equal to gm, and the limit, when we substitute the limit, then it would be 0 minus 1 upon under root of r square plus r square. So Vp gravitational potential would be equal to minus of gm by under root of r square plus r square. This is the gravitational potential, and we can see that at center of ring, it is maximum, and therefore V center of the ring is gm, in fact minus gm by r at the center of the ring. Okay, and at infinity V is 0. And if we draw the graph of this potential, then it would be inverse relationship graph like that. And this is V and this is R, and this would be minus gm by r. Okay, so this is the final graph of the potential of a ring. Now let's move on the next figure. Now in this figure you can see that we have to find out the gravitational potential due to a linear wire. Okay, linear wire on which the mass is distributed on a line. So we can say that again, let us consider 2 points. One is A and another is infinity. And we know that the gravitational field intensity due to this linear wire can be easily calculated by the electric field intensity, which is 2k lambda by r. So you can what you can do, you can just use the formula. Instead of this 2, this is 2, instead of k it is g, and lambda is here is mass per unit length, and r is the distance, instantaneous distance. Okay, so this is the gravitational field intensity due to a long linear wire. So now we know that the direction of I would be towards the wire because it is always attractive, and when we are moving away from point A, then the angle between dr and I is 180 degree. So dv is equal to integration minus of integration I dot dr, and dv will be v infinity minus va, which is minus of I, which is 2g lambda by r, and dr, and the angle between I and dr is 180, therefore there would be a plus sign. The limit would be from r to infinity, and this va would be equal to minus of 2g lambda ln r, and the limit would be from r to infinity. So va, you can see that there would be a term log infinity, and log infinity is not defined, so va is not defined. So we can say that the gravitational potential due to a linear wire is not defined, and the gravitational potential difference is defined, because now if we have to find out the difference, gravitational potential difference, so we can say that there is a wire, linear wire, this is a linear wire, and this linear wire has a length of infinity, and there are 2 points A and another point B. This distance is RA and this distance is RB. So if we are finding out the potential difference, then we can say that dV will be equal to minus of integration I dot dr, and obviously I am moving from A to B, so dr would be from A to B and I would be from B to A. So dV is VB minus VA, and it is equal to minus of integration of G 2g lambda by r and dr, and the angle is 180 degree, therefore there would be a plus sign. So VB minus VA will be equal to integration of g lambda integration of 1 upon r dr, and the limit of r would be from RA to RB, RA to RB. So VB minus VA will be equal to 2g lambda, in fact this is 2g lambda, and ln RB by RA. And you know that we have to represent the gravitational potential with a negative sign, because This negative sign represents that the gravitational potential is gravitational field is always attractive. So VA minus VB will be equal to minus of 2 G lambda ln RB by RA. This is the potential difference due to a linear wire.